Example 2.13. So we have one shed, something like this. Okay. And in this shed we have frames, steel frames. How much is this width?
6 meters.
You want to keep the same or you want to change it?
The same.
And the height is,
No, 63.
how much is the height?
3
So 6.
3 meters. 3 meters.
And what is the question? Would you like to state? Would any one of you can read the question?
Yeah. The side of the building in figure 233A is subjected to a wind loading that creates a uniform normal pressure of 15 kilopascal on the windward side and a suction pressure of 5 kilopascal on the leeward side. Determine the horizontal and vertical components of reaction at the pin connections A, B, and C of the supporting gable arch.
A, B,
C.
B is gable here.
Yeah, B at the top.
And what about these end conditions? These are
Teacher? What?
hinges or rollers or what?
Pins.
Is there any pin at the top?
Yes, yes. It is B.
No.
It's in the middle, so A, B, in the middle, what's in the
Middle is where? B or
B.
C?
Yeah, B. In the middle. A and C.
A and B also, or
A and C on the bottom.
A, B, and C.
It's fine. This is same thing. I mean, these are the frames, 3 frames.
Oh, and just
These are 3 frames, and on these 3 frames, your building is resting. Okay. So what we have to do?
Determine the horizontal and vertical components of reaction at the pin connections.
So
A
we
and C.
need the reactions. I'm not going to tell you which one is the windward and which one is the leeward. You know that we already discussed all these things in the chapter number 1.
Facing the wind.
Yeah, so we can take the highest pressure 15 kilopascal, and how much is the spacing of these frames?
4 meters.
4 meter, 4 meter. Okay, so if we talk about this frame, how much would be the area supported by this frame?
Half, so 2 meters.
Yeah, 2 meter from this side and 2 meter from the other side. So if I want to convert this pressure into a force, the force per unit length, how much will be that force?
15 into
Multiply by the width.
the width. 15
You will get load per unit length.
Yes.
Okay. So let me draw the frame here. And you have pink here, and I think you have one gable. Gable frame has one hinge at the top,
Yes.
and the load acting is, how did you get 60? 15 into 4.
Yes.
And wind load is always acting perpendicular, like this.
Yeah.
It is inclined. I think my throat is getting a little bit tight. Let me get rid of it. I'm sorry. I don't know, maybe when I move my arm a little bit up. So, this one, This one would be how much? How much would be the pressure at the top and here? So
5 kilopascal, which is into 4, so
it will become how much?
20.
20
20
kilopascal per
So this is, these two are the windward sides and these two are the leeward sides. So the wind force, windward side, wind force, windward side or windward roof and wall will be 60
kilopascal, kilonewton per meter.
15 into 4, 60 kilonewton per meter.
Yes.
And on leeward side, it will be
5 multiplied by 4.
5 by 4, it will be 20.
Yeah.
So now you can put the values here. It is upward or downward, this one?
It should be downwards because it's facing.
Yes. So 60 here and 20 here. Sorry, here 60. Please, if I do some mistake, correct me, okay? And what about here? Downward or upward?
Upwards.
Yeah, you know it. So it's 20 and 20.
So teacher, if
There's a hint here.
yeah, so teacher, if the windward wall is facing a pressure of something, we subject the same load on the windward roof, like the same, or is there an
I did
equation?
not understand your question.
Like here we have 60 kilonewton per meter for the windward wall, but it wasn't mentioned in the question what was subjected to the windward roof, the side of the roof.
Actually, the roof which is facing the wind is known as windward roof.
Yes.
Okay. So the windward means the wind pressure is acting this way,
Yeah.
direct on that. Leeward mean going away.
Yes.
So that's why we have shown the leeward away and the windward towards. It's like, for example, once the wind will blow, if you see the wind will go like this, strike on the walls straight like this, and same here. But if the wind is blowing this way, of course it will give pressure this way.
Teacher, I'm not talking about the size. I got the idea now. I was asking about the value. That's it.
Okay. The roof and wall facing the wind is known as windward,
Yeah.
and that will be having 60.
So the same value for.
Yeah. Okay. Now, you have two things. First, we will consider this structure as a whole, and is it determinate? Is it determinate?
Two. Since it's fixed, we can also make a section as well.
Is it determinate?
Yes, determined.
Yes, it is determinate. Two parts. This structure has how many parts? Two parts. One part and two parts. There is one hinge here. There is one hinge only. One hinge means it is. If it is rigid, it is one part.
I mean the number of members, 2 or
Two. This is what I am telling you. That this is whole as one part. So how many parts?
Two. Teacher, here we have two members that are fixed to each other.
Yes.
Don't we make a section or just assume that it's one?
No, it's a steel structure. You have a pin here. Okay. Okay. Now let's move next. Simon, please. We have short of time and I have to finish your problem today. Time is 10:45. Okay.
I will notify you.
Yeah, please. Okay, so now next we have to, what is the question? We have to find out the reactions. So we have two ways. The one way we keep the load as it is and we find out the reaction. The other way we convert these uniformly distributed loads to the point loads. So how
By height.
you want to convert these UDLs to the point loads or you want to keep them as it is?
Point load.
Okay, point load. So let's convert these loads into the point loads. So it's very simple.
60 into 3.
Victor,
Yes.
how we can make it like this and solve it?
Or we can make what?
How can we make it like a brush up and solve it? We
Like
have
a
to use-
UDL?
Yes, we have to use moment, and how we can use moment with brush.
We can calculate. Like if it is a moment, I want to calculate the moment here. How much will be the moment? 60 into 3 multiplied by 1.5. It will be same.
Ah.
Do you understand or not?
Yes. So we have to convert it.
So it's your choice, but the effect is different. You know, the point load has shear force diagram straight,
Yeah.
but the UDL has
Like
like
incline or decline.
yeah, incline and decline. And similarly, the moment diagram for point load is like a triangle, but for UDL it's like a curve.
Yeah. Geometry.
So the effect is different. Okay, keep in your mind. Okay, so you want to convert those loads into the point loads. So here we have 60 into 3, 180 kilonewton. Here we have how much?
60
Same.
No.
Make sure.
45 degree.
How much is the length? 3 square plus 3 square square root.
Integral.
Do you have calculator? No? If you don't have calculator,
That should be 4.24 meter.
multiply by 60.
254.
200.
54.
And how much is this load? This upward, like this.
85.
85.9.
85.
Yeah, 85.
And what about this? 60.
Yeah, it should be 6.
60 into 3. Yeah.
So you know, I told you that if we have a hinge, for example, if this is a beam, and we provide a hinge here. So hinge means there will be two reactions here. If I
Yes.
divide, I told you, for example, you can assume any direction.
Normal and
You can assume any direction. For example, if you assume this way on the left side, then on the right side it would be opposite. It would be downward and
the right.
right. So you have one hinge at the center. So we have like, how many reactions we have?
6.
6. What are the name of those reactions?
AX, AY, BX, BY, CX, CY.
Yes. 2 at this point, 2 here and 2 here. So let me show first the two reactions here. What direction you want to assume? You can assume any direction, whatever you like.
It should be upwards. Opposite
Downward.
Okay, you want upward or downward?
Downward.
Downward?
Because of brush.
Up to you. You don't know.
Upward.
Upward or downward? At the moment you don't know.
If it's negative, we will change.
If it is positive, it means your assumed direction is correct. And if it is negative, it means your assumed direction is wrong.
The other way.
But you can assume any direction, whatever you like. So, downward or upward?
Downward.
Let's say downward, yeah.
Okay, right or left?
Left.
This way?
Yeah.
And what about here? Upward or downward?
The opposite of
Opposite of brush other way.
This and
to the right.
okay. So what are these reactions? It is A,
Just here. That's C. So
CX, CY.
AY.
Let's first apply sigma fx and sigma fy and let's check whether we can solve it or not. Sigma fy for the whole structure, for whole frame.
Minus
Minus AY plus CY. Next.
minus 2, 5,
Minus
4,
254.
sine 45.
And 25.
It is 45. So
Sine 45.
then
Plus 85, sine 45.
is equal to 0.
0.
Yes.
Two unknowns.
So, and
What about the reaction of the pin? B.
ما بعد consider.
That's the pin. We will take that, but not now. Now we are considering the whole structure as a one unit.
Okay.
Once you consider each part, that time you have to consider the reaction. Okay? So sigma fx. Also you cannot find. What about sigma moment at point A?
Yes,
Yeah.
give you CY.
CY.
Yes, you can find Cy. Okay, so how much will be the moment? 180? 180? Positive or negative? You can say counterclockwise positive and clockwise negative.
Yes.
So
180 to 3.
clockwise
Minus 180 to 3.
118 to 1.5.
1.5. Yeah.
no 3 or 1.5?
3.
1.5.
3.
It's in the middle.
1.5. And
Then 254 sine.
plus or minus?
Will be
No, plus. It will be counterclockwise.
Really?
Minus.
Two
reactions. It has two
Will be
reactions.
minus.
I was talking about the downward zone.
Minus.
What about this? The moment of this load at this point?
Minus. Same one.
Minus.
Yeah.
At point A, I am calculating moment at point A. Minus 254
Sine
sine 45 into
1.5.
into 1.5
Yeah.
No.
minus 254 cos 45 into 4.5. It has two components, one vertical, one horizontal.
And 85 also.
85 will produce which moment at this point, clockwise or counterclockwise?
85 will be minus.
It should be plus.
Plus the y component plus the y.
What is minus 1?
Plus,
We are calculating moment at point A.
All
Minus.
minus. Minus. Clockwise.
One minus one plus.
Teacher,
Just trying
the
to-
vertical,
Plus.
the vertical component will be positive, but to the
X components will be negative.
yeah.
Yes. You're right. Okay, so minus, silent place, plus, vertical component plus,
85 sine
into what? 4.5
Yes, okay.
minus 85 cos 45 into
The
Same.
45.
yeah.
and now this for 60 silent place
minus 60.
See here. Minus 60 into
1.5.
and what about CY?
The plus CY.
Minus 6.
Is equal to 0.
6, 6, yes.
6, no.
So in this equation, only CY is unknown, so please find CY. It's a 1 minute job.
$240.
240,
240.
20,
240.
240. Positive or negative?
Is it negative?
Forget.
Positive.
Positive?
Yes.
Wait.
Hi guys. Hello at the end. What are you doing?
This is negative.
What are you doing? Okay, let me see. See. Be with me in the class. Else it will be trouble for you.
240.
There will be one question from this in your final exam. Not on in your final, in your next exam. From this and the homework I will give. And that will be, the marks for this one question will be equal to the, or greater than the marks of your quiz. Do you understand? Positive?
Positive 240.
It's fine. So why you are so much worried? Tell me.
Yeah.
What will happen? It will be wrong?
No more.
Okay. CY is positive
And then let's and let's see.
240.
So 13.
So if CY is 240, silent please, how much will be AY?
120.
Put CY in this equation, you will get AY.
120.
120.5.
120.
120.5.
120.
Positive, it means your assumed directions are correct. If the answers are negative, it means your assumed directions are wrong. Next we have to find out AX, CX, BX and BY. So now how many unknowns we have? 4. So what we can do now, now we can divide our structures into parts.
By the way, teacher, the sprayer there helps a lot and cleaning.
Okay. So let's solve first the left part. This is point B. Now I will divide this structure into the 2 parts. The left part
Maybe.
AB,
Yes.
and now I'm drawing the free body. It means I can show the reaction. This is how much? AY positive
240.
Yeah.
and
240. Why?
No, correct.
okay. This is AX.
Yes, unknown.
And what about this reaction or the reaction at these point? Sorry, at this point.
Two reactions with the
Right.
same
Good.
inclination. So normal,
How you want to assume the directions? Which way?
Right.
same as the member.
Like this?
No.
No, no. Opposite of the AY.
Right and dark.
You want to assume like this,
Yes. And right.
or left or right?
No, this right.
Like this?
Yeah. Will be this equal this.
Sorry?
Will be ax equal.
This you can say bx and you can say this by. And here you have one force, how much?
180.
And you have one force here at the mid.
254. 5.
Okay, let's apply sigma Fy is equal to 0 for this member. Remember, it is a very important point. If your whole structure is in equilibrium, all parts of that structure will be in equilibrium. Do you understand?
Yes.
Good. So it means that if this structure is in equilibrium, like we use the conditions, it means all the parts will also be in equilibrium. So this equation should satisfy.
300.
So it means minus 120.5
Minus 254 cosine of sine theta.
cosine.
Yes, cosine of sine.
Cosine or sine?
The same answer.
Answer is same. Correct. Plus by
Yes, will equal to 0.
300.
300.5.
300 kilometer. Now sigma fx. Can we use sigma fx, or let's take moment at point A?
Yes.
Let's take moment sigma moment at point A is equal to 0.
Minus-
So these two forces will become 0
Minus 1.
Minus 180.
into
1.5.
minus like the same 254
Sine 45.
into
1.5.
sine 45 into 1.5
Yes.
minus 254
Sine 45.
into
4.5.
4.5. Anything else?
Yes.
Vy into 3.
Yeah. dx.
So you can find dy from this equation.
dx.
Also dx.
dx.
Oh, sorry. Yes, dx.
dx by 4.5.
How much?
449.
Should not be 0 here. Bx should be negative.
Yes.
Bx.
6.
449.
So from here you have by. By is 300. You can put the value of by here. So you will get bx. Sorry.
The bx multiplied by 6 or 4.5.
Bx multiplied by 6. You're right. Because this point is the total height 6. What is the answer? Bx? Move your fingers quickly on the calculator. You are sitting in structural analysis class.
I got 75,
75.
but the other direction.
Okay, negative.
Yeah.